Hello everybody, welcome into another lesson. So today we are going to talk about the surface area of cubes, of prisms, and of cylinders. So what is the surface area? The surface area covers, it's the total area of the outside of the 3D object, of the figure, whereas the volume is the total amount of space that'll fill that 3D object. The surface area just covers the outside of the object. So for example, if you're going to paint your house, right? You don't want to find the volume of your house. You don't want to fill your house up with paint. No, you want to find the surface area, the area of the outside of your house, so you can paint the outside of your house. That's why you would want to find the surface area. That's just one of many examples. But we'll take a cube to start. A cube is probably the easiest one to find the surface area of. If we recall, every face on the cube is a perfect square. All 6 faces. There are 6 faces on a cube. Or actually on a prism also. Well, on a cube, I should say. Prisms can vary because of the number of sides, but there are 6 faces on a cube, and they're all perfect squares. Well, to find the area of a square, you take a side and set that to the second power. You would find the area of one square if you did that. To find the coverage of the total surface area, you'd have to do that with all 6 squares, add them together, and you'd come up with 6 times the area of a square, or 6 times the side squared. That gives you the surface area of a square. I'll do 2 examples for the surface area of a cube, because a cube's relatively easy. Let's say we have 3 meters. So we want to find the surface area of a cube with a side length of 3 meters. You would just take 6 times that 3 meters to the second power. Well, order of operations dictates we do the exponents first. At 3 meters to the second power, you still have 6 on the outside, but 3 to the second power is 9. Meters to the second power is square meters. So you would have 6 times 9 square meters. That would give you 54 square meters. So the surface area of this cube is going to be 54 square meters. That's exactly what you would get. Alright, let's do one more example. Let's say we have a length of 5 feet for a side. So to find the surface area of this cube, you would take 6 times that length of 5 feet to the second power. That 5 feet quantity would be to the second power. Well, you still have 6 on the outside, but we got to do that 5 to the second power. That'd be 25. Feet to the second power, well, that's square feet. So then you would have 6 times 25, well, that'd be 150. Then feet to the second power, that's still square feet. So the surface area of this cube is going to be 150 square feet. That's exactly what you would get. Cubes are really very easy, to be quite honest. Okay. I think we're ready to move on to a prism. For today's purposes, we will deal with a rectangular prism. There's all kinds of prisms again. We know from studying volume, the same is true with surface area. There's all kinds of prisms we can do. But I think a rectangular prism will probably be the easiest. So first, let's draw said prism. Alright, let's do that. Alright, let's go ahead and connect our points. Not bragging on myself because I'm not a great drawer, of course. I'm not a great artist, but I think I'm getting better at drawing these 3D shapes. I feel like I'm getting better at it. Okay. Define the area of a prism in general, or a cylinder, which we'll cover cylinders in a minute. But the surface area of a prism or a cylinder is going to be equal to the lateral area plus twice the area of a base. Okay, well, what the heck is the lateral area? The lateral area is equal to, the lateral area is the perimeter of the base times the height of the prism. That's what the lateral area is. It's the perimeter of the base times the height of the prism. Then you still have twice the area of the base. Well, this is where it gets to be a bit of a doozy. The perimeter of the base, which is a rectangle, remember the perimeter of a rectangle is twice the length plus twice the width. You'll take that times the height plus twice the area of the base. Well, let's deal with the distributive property here on the lateral area. 2L times H, that would be 2HL, or twice the height times the length, plus 2W times H, that would be 2HW, or twice the height times the width, plus twice the area of the base. Well, what is the area of a base of a rectangular prism, which the base being a rectangle? Well, we still have our formula so far for the lateral area being twice the height times the length plus twice the height times the width. Plus we have 2 times the area of the base, which is a rectangle. The area of a rectangle is length times width, right? So therefore, the formula is going to be equal to twice the height times the length plus twice the height times the width plus twice the length times the width. That is the lateral area, that is the surface area formula for a rectangular prism, excuse me. Do I expect you to remember the final result formula that we just got? Heavens no. No, not at all. In fact, if you just try to commit that formula to memory, that really shows me you don't understand it. Because what you really need to remember is the surface area equals the lateral area plus twice the base. That's really what you need to remember. Whether it's a prism of any type or a cylinder, it's the lateral area plus twice the base. That'll give you your surface area. And then remember, your lateral area is going to be the perimeter of the base times the height of the prism. That's what the lateral area is, plus twice the area of the base for your prism. If you can remember up to this step, you can derive the formula for the surface area, for the type of prism you have. If you can remember that far, you can derive the formula, just input the values for perimeter, what the perimeter of a base is, and then what the area of the base is. You can derive all that and get yourself this formula. This, if you remember up to this far, that'll show me that you understand it. And granted, I don't give you tests, I have no way to measure it, but just trying to commit the final result formula to memory, that's not understanding it. The surface area, whether again it's a prism or a cylinder, being the lateral area plus twice the area of a base, that's what you need to remember. And then the lateral area is nothing more than the perimeter of the base times the height of the prism, plus then you have your area plus twice the area of your base being your surface area. If you can remember that, you can derive your formulas. So let's do 3 examples here, okay? Let's say we have a 20 centimeter length for the rectangular prism. We have a 20 centimeter length. We have a width of 10 centimeters. Then we have a height of 8 centimeters. Alright, so the length of the rectangular prism is 20 centimeters. Your width is 10 centimeters. The height of the prism is 8 centimeters. We want to find the surface area of this rectangular prism. We're going to take our final result formula. We'll have 2 times whatever the height is, which would be 8 centimeters. That's a horrible parenthesis. Pardon me. 2 times 8 centimeters times your length, which would be 20 centimeters, plus 2 times your height, which was 8 centimeters, times your width, which was 10 centimeters, plus 2 times your length, which was 20 centimeters, times your width, which was 10 centimeters. Yes, I know this looks long and horrific, but so all you're doing is taking this formula, you're plugging your height, length, and width values into it. That's all you're doing. Now you're down to simple order of operations. Order of operations dictates, of course, you do the multiplication first. 2 times 8 is 16 times 20, that'd be 320. Centimeters times centimeters, that is square centimeters. Then you have plus, then you have 2 times 8 is 16 times 10, that's 160. Centimeters times centimeters, that's square centimeters. Plus, you have 2 times 20, which is 40 times 10, that's 400. Centimeters times centimeters, that is square centimeters. So now all you got to do is add those 3 together, you got your surface area. So 320 plus 160 is 480 plus 400, that'd be 880. So the surface area of this rectangular prism would be 880 square centimeters. That's exactly what you get, is 880 square centimeters. Yes, I got 2 more examples. We got 2 more examples here. Alright, let's see. We have 30 inches for the length, 15 inches for the width, 10 inches for the height. Alright, so we have a rectangular prism with length of 30 inches, width of 15 inches, and a height of the prism of 10 inches. So once again, we want to find the surface area of this prism. So in order to do that, we're going to take our final result formula. We'll take twice the height, which was 10 inches, times the length, which was 30 inches, plus twice the height, which was 10 inches, times the width, which was 15 inches, plus twice the length of 30 inches, times the width of 15 inches. Alright, so now order of operations dictates we do all the multiplication first. So 2 times 10 is 20, times 30, that's 600. You would get 600 square inches, plus 2 times 10 is 20 times 15. That's going to be 300 square inches, plus 2 times 30, that's 60 times 15. That'd be 900. You would get 900 square inches. So now all you got to do is add these up. 600 plus 300 is 900, plus 900, that's 1800. You would get 1,800 square inches for the surface area of this rectangular prism. It would be 1,800 square inches is exactly what you would get for the surface area. And I'll do one more for the surface area of a prism. We're not going to cover the other types of prisms today because there are infinite possibilities for prisms. If you could just remember these two basic steps of the formula for a surface area, you can derive the formula for any type of prism. Alright, let's say we'll do millimeters. 9 millimeters for the length. Let's do 7 millimeters for the width, 6 millimeters for the height. Alright, so we're going to do a rectangular prism, find the surface area with a length of 9 millimeters, a width of 7 millimeters, and a height of 6 millimeters. So let's go ahead and find that surface area. Let me start back here a little more. So the surface area is equal to twice the height, which would be 6 millimeters, times the length, which is 9 millimeters, plus twice the height, which again is 6 millimeters, times the width, which is 7 millimeters, plus twice the length, which is 9 millimeters, times the width, which is 7 millimeters. Alright, now we got to go ahead and do the multiplication first. So 2 times 6 is 12 times 9, that's 108. Millimeters times millimeters is square millimeters, so you'll have 108 square millimeters, plus 2 times 6 is 12 times 7, that's 84. Millimeters times millimeters is square millimeters, plus 2 times 9 is 18 times 7. I need to figure out 18 times 7. I don't know that off the top of my head. 18 times 7 is 126. So that'd be plus 126 square millimeters. Now we're just going to go ahead and add all these together, and we will have our surface area. So 108 plus 84 plus 126, that's 318. So the surface area is 318 square millimeters. That's exactly what you get, 318 square millimeters. Alright, so I think we've done enough for a prism. Again, prism or rectangle, forget about everything below here and below. Remember up above the eraser, surface area equals the lateral area plus twice the area of the base, whether it's a prism or a rectangle. The lateral area is the perimeter of the base times the height of the prism. That's what the lateral area is. So if you could do that plus twice the area of the base, you'll have your surface area. Then you just got to derive your formula by putting in what the perimeter of your particular base is, and then whatever the area of your base is for whatever shape you have for the base of your prism, you got it. Okay. We are going to do cylinders now. We will find the surface area of cylinders. So let me go ahead and draw a lovely cylinder real quick. Alright, a cylinder. Alright, let's go ahead, draw the cylinder. Let's put a radius in one of the circles. Radius R. We'll have the height, of course. So, okay, we got ourselves a cylinder with a radius of a circle and the height of the cylinder. As I said when we were doing prisms, it's the same philosophy with a cylinder, even with surface area. It's the lateral area plus twice the area of a base. Which is still true. It's the perimeter of a base times the height of the prism plus twice the area of a base. Now this is where it gets interesting since it's a cylinder. What is the perimeter of a circle? Because it's the perimeter of a base. What's the perimeter of a circle? It's also known as the circumference. The circumference of a circle is 2 pi r, right? You'd have 2 pi r, all that times the height, plus twice the area of the base. So that's the perimeter of a circle, is 2 pi r, which is the circumference. So far what you have is 2 pi RH plus twice the area of a base. Now, what is the area of the base of a circle? Let's still keep our 2 pi RH plus 2 times what is the area, or the area of a circle? Well, that's pi r squared, right? So what you're going to have is 2 pi RH plus 2 pi r squared. That's ultimately the formula you would get for the surface area of a cylinder. 2 pi RH plus 2 pi r squared. That's the surface area of a cylinder. Again, do I expect you to remember the final result formula? Heavens no, I don't. Just remember, surface area, lateral area plus twice the area of a base. The lateral area being the perimeter of a base times the height plus twice the area of the base. That'll give you your surface area. So let's do 3 examples for a cylinder, because I like to do it in 3s. Except for cubes, we only did it in 2 because that was pretty easy. Alright, let's say we have a radius of 10 inches. We have a height of 30 inches. So we want to find the surface area of this prism. So the surface area is going to be equal to 2 pi times your radius, which is 10 inches, times your height, which is 30 inches, plus 2 pi times your radius of 10 inches. That'd have to be raised to the 2nd power. So let's see. 2 times 10 is 20 times 30. That's 600 pi. You'll have 600 times pi. Inches times inches is, well, square inches. plus you'll have 2 pi times, you got 10 to the second power, that's 100 inches to the second power. Well, it's just that, it's square inches. So what you'll have is 600 pi inches squared plus 2 pi times 100. That'd be 200 pi square inches. So that's going to equal 600 plus 200 pi. 600 pi plus 200 pi, that's 800 pi. You'll have 800 pi square inches, which if we go ahead and round that to the nearest 2 decimal places, we'll take 800 times pi, we'll round that to the nearest 2 decimal places. 800 pi, that is 2,513.27. So 2,513.27 square inches. So the surface area of the cylinder is approximately 2,513.27 square inches. That's what you would get. And I got more examples here. We'll do 2 more examples. So yeah, surface area is definitely different than volume. All right. Let's say I got 5 centimeters for the length of the radius. Then I have 15 centimeters for the height. Alright, so I want to find the surface area of the cylinder. That's going to be equal to 2 pi times the radius of 5 centimeters times the height, which is 15 centimeters, plus 2 pi times that radius of 5 centimeters to the second power. Once I plug all these into the final formula here, once I plug the radius and height values in, this is what I get. Okay, so now we do the math. We'll ignore pi for a minute. We'll do 2 times 5 is 10 times 15. That's 150 pi. And centimeters times centimeters, that's square centimeters. Plus 2 pi. Then you have 5 to the second power. That's 25 centimeters to the second power. So then I'll have 150 pi centimeters. It's always best to leave pi alone and do it at the very end. I would almost treat your pi like a variable and do that at the very end. So then you have 2 times 25 is 50, so that would give you 50 pi square centimeters. Well, 150 pi plus 50 pi, that's 200 pi. You would get 200 pi square centimeters, which if we do the decimal approximation to 2 decimal places, here's what we'll get. 200 pi is about 628.32. So 628.32 square centimeters is the approximate surface area of this cylinder. 628.32 square centimeters. Alright. As I said, we do one more. Alright. Say the radius is 1 yard, the height is 3 yards. We have a radius of 1 yard, a height of 3 yards. So the surface area is going to be equal to 2 pi times my radius of 1 yard times my height of 3 yards plus 2 pi times my radius of 1 yard, that quantity to the second power. So what I'll get here for the left term, we'll ignore the pi for a minute. 2 times 1 is 2 times 3 is 6. So I'll have 6 pi, then yards times yards, that's square yards. So I'll have 6 pi square yards plus 2 pi, then we'll have times 1 yard squared. Well, 1 squared is just 1, so we'll have 2 pi yard squared is yard squared. So in the end, we add these up. 6 pi plus 2 pi is 8 pi. Then we'll have yards squared. So when we do the math here, when we do 8 times pi, we'll do an approximation of 2 decimal places. So 8 pi is about 25.13. So the surface area of this particular cylinder is about 25.13 square yards. That's exactly what you would get. 25.13 square yards for the surface area. So a recap, if you're doing a cube, that's the easiest surface area of all to do. All you have to do is take 6 times the side squared, you got your surface area. What I really want to drive home is, forget about all this here, okay? I want you guys, heck, forget this part. What you need to remember, I'm going to hammer it one more time before we go. For a prism and a cylinder, for a prism and a cylinder, the surface area is equal to the lateral area of your prism or cylinder plus twice the area of the base. Remember that. Your lateral area is equal to the perimeter of the base times the height of the prism or the cylinder plus twice the area of the base. That's all you need to remember for your surface area. If you can remember these, you can derive the actual formula for the particular prism or the cylinder that you're working with. If you can do that, you've got surface area. But next lesson, we're going to talk about the surface area of pyramids, cones, and spheres. So I hope everybody has a good night. Take care.